In this video, we're going to create a geometry node setup for rectangular baskets. It actually turned out to be a lot more complicated than the round baskets we made in the last one, but I will be reusing a lot of the node groups that we created for that. So I'm going to put a link up here so you can go back and follow that one first if you'd like. I got a lot of great feedback on that video, and I actually went back and refilmed a few parts of this one to include fixes to issues that people found. So in the later half of this video, there are some bonus tips that you can use to improve the round baskets, and I'm really happy with the way this turned out the second time around. So I do want to thank everyone who provided that great feedback, and I think that's everything. So let's get started. Okay, so let's jump straight into geometry nodes. And before we get too far into this, let's lay out the basic game plan. What I'm planning to do, we'll start with a nice round corner here, and then we're going to connect a couple of straight line horizontals to that. And then all we're going to do is mirror that geometry around for the rest of the basket. So let's start with this round corner here. Create a new geometry node setup, and let's make some space so you can see what's going on. So to get that corner arc, very simple, we're just going to add in an arc. And first thing, we only need to sweep through 90 degrees. And I'm going to drop that resolution down to 4. Now we can connect the radius to the group input, and we'll set that down to 0.04. That's what I've been using for this tutorial. And then we want to actually move this corner to where it's going to be on the final basket. And in order to do that, let me just bring up this side panel here and add a couple of inputs. So we're going to have the X dimension, and we'll also add in a Y dimension. And because we're only creating 1/4 of the basket, we're actually going to need to divide those dimensions by 2 and also subtract the radius so that this point ends up exactly where it needs to be. Let's start with a set position node. And we're going to take this offset and connect it to a combine XYZ right down here. And then take this X dimension and divide it by 2. And then go to a subtract. And bring in the radius and connect that to the X dimension. Oh, also you can set these X and Y dimensions using 0.2 and 0.4. So then you can duplicate these math nodes, bring that down here, connect your Y dimension, and remember to connect your radius into the subtract, and then plug that into the Y. And now that corner is right where we want it. Let's take all of this, let's clean that up and put it in a frame, and we'll call that corner arc. And now we're going to create the profile for the basket, and we're going to put that on a 45-degree angle, and that way we can instance this corner arc on those points. And this is going to look familiar if you watch the round basket tutorial. So let's do a Bezier segment. Zoom in here and Alt-Shift-click so we can see what we're working on. Let me jump to the front orthographic. We're going to put this X at the origin, or the start point at the origin. And then, like we did before, let's run this to a combine XYZ, and we can duplicate that down here and use it for the end handle and also the end point. And rather than connect these up to our original group input, I'm just going to bring in another group input, plug that in here, and we can connect our X and Z for all these to the outside. I actually learned this profile trick from a C. Bailey film, or actually it was Chris Bailey on on CG Cookie. I'll put a link in the description for there's a vase tutorial. Let's go ahead and rename these. So we'll have start handle X, start handle Z, do end handle X, end handle Z, and end X, and finally end Z. So now from this front orthographic, I'm going to move our endpoint up to 0.3 and out to 0.1. I'm going to put the end handle at 0.15 on the Z and leave the X at 0. And then the start handle, I'll move up to 0.1 and then out to 0.15. And there you go. So that gives us an interesting profile to work with. So in order to make this for the corner, what I want to do is have this on a 45-degree angle. And you could go through the math, rotate it and scale it. But I found that to be a little unreliable. So what I was doing, and this is actually a lot easier to set up, it's a lot more straightforward. We're just going to do a set position node. And we're going to offset that. So we already have the X, all we need is the Y. So not the position, let's go from the offset to a combine XYZ. And we're going to set the Y of that offset to a separate XYZ and connect it to the X. And then we'll just take that to a position input. So all we're doing here is taking the X from the original profile and copying that to the Y dimension. Now, right now it looks a little funky. That's because we only have those 2 points to work with. So we'll add in, we're going to add in a resample curve node. And I just want to set this to evaluated, that way we can control it from this original. But now we have our profile running up that 45. So if you look from the front orthographic or the right side orthographic, it should look identical. And while I'm here, let's just clean this up. We'll put this all in a nice frame, and we're going to name this corner profile. And then we can take all of that and use that for an instance on points and connect our corner arc as the instances. In order to complete the horizontals for the basket, all we need to do is instance straight lines onto these arcs, onto both endpoints. So to do that, let me make some space over here, and also I'm going to hide this end panel, side panel. First thing we're going to do, we're just going to copy this instance on points, and this is where we're going to bring in those straight lines to instance onto the endpoints there. So first off, we're going to make these horizontal lines straight in the Y, -1 on the Y. But now they're instance on all 4 points of our corner arc, and we only want the endpoints. So let's connect to this selection. We'll do an endpoint selection. And I believe we only want the start point. I'm going to add in a join geometry node here so we can see where we're actually connected. Bring that down a little bit. So now we've got those connected where we want them, but we need to address the scale here. So we can just connect a different scale to the instance on points node. So let's bring in a position node, if I can spell position. And we'll connect that to a separate XYZ. And now on the y side here, all we need is the y coordinate of the endpoints of that arc on its way up the corner. So let's take the y coordinate here, and we're just going to divide by the length of our straight line. Connect that there, and then we should just be able to connect this into the scale. But you can see it's only given us the scale, the correct scale for the bottom instance, and then it's used that same scale all the way up. All we need to do to fix that is just put in our realized instances. And now it's got the correct scale for all the instances as they go up that's our y side. So now we could go ahead and duplicate all of the nodes that we just created and reuse them for this y side. But if you go down on this endpoint selection and just put the endpoint back in, we've already got all of those instances where we want them. All we need to do is rotate them and scale them, and we'll have the x side as well. So let's add in a rotate instances. And let's see, we need negative 90 degrees for the rotation, but obviously we don't want to rotate all of them. And I could use a capture attribute node to do this, but I happen to know, because I've done this a few times before, that I'm going to reuse the x side and also the y side. I'm going to need those separated out later. So instead of a capture attribute, I'm just going to use a store named attribute. Connect that there. And I'm going to change this to Boolean. Let's see. Move some of this over. So this is going to be for the x side. And let's just duplicate this endpoint selection. And all I need is the endpoint. So we'll connect that up there. And then in order to use the correct selection on our rotation, all we need is a named attribute input. Put that here, change this to Boolean, and we should just be able to select our x side variable that we just made. And that deselects this y side, and only the x side got rotated. But now we need to address the scale on this side as well. So if you remember, when we did this y side, we needed the y coordinate of the position. For the x side, we only need the x side, so for the x coordinate. So we're just going to switch between these. So if I bring in a switch node and change this to float, plug that in. So when it's not the x side, we want the y coordinate. When it is the x side, we want the x coordinate. So we're going to connect this x to true, and then connect this selection here to the switch. And now we have our x side correctly scaled as well. And while we're here, like I said, we're going to need the x or the y side as well. We're going to need to be able to separate that out. So let's duplicate our store named attribute and rename this to y side. And then going to copy this endpoint selection. And instead of the endpoint, I just want the start point, and we'll connect that in for the value there. And just to double check that we're doing this correctly, we're going to separate, oops, not separate x, y, z. Let's do separate geometry. And we can just copy this named attribute node that we just made. We'll bring this up and connect that in. And this needs to be instance. So that's our x side, and we should just be able to select. Did we change this? We didn't change this to y side. Make sure that's actually y side. And now we should have a y side here as well. And we're also going to need to separate out the top and bottom horizontals. We're going to use the bottom horizontal to instance all the verticals for the basket, and the top and the bottom we're actually going to need together for the decorative rim node that we actually made in the previous tutorial. So in order to get the top and bottom separated, let's go over, this is that first instance on points. We're going to take that and plug it into an attribute statistic node. And for the attribute, we're just going to use the index. And what we want is not the index for the points. We actually want the index for each of the instances. And this is the instances of the corner arc. So we're going to compare the minimum and the maximum. So we can plug in our index to those. And we can actually duplicate a store named attribute. Put that here. And we're going to name this top because we're going to connect our maximum to this one. And this also needs to change from point to instance. And then we can duplicate that again and call this bottom and connect our minimum to that. And then I also want to make sure, actually I can show you why. So if we select top, we have the top, but we're missing that corner arc. And that's because right now we're not storing that attribute on the geometry for those corner arcs. So we can sever this connection, and then from this top named attribute node, we can just connect that to the join geometry. And now we have that corner arc included in the top horizontal. And then we should have the same thing for our bottom horizontal. Let's put it in a frame and rename this to basket horizontals. With our bottom horizontal selected, we can go ahead and start instancing our verticals. So I'm going to create a little bit more space over here. And right after this separate geometry, let's add in an instance on points. And for the instances on that, we're actually going to use from this corner profile that we created. We're going to plug that into our instances. And that looks a little goofy, but that's because we need to realize instances. So let's come in right here. We'll plug in a realize instances. And now, because we realized instances, we can't use instance on this separate geometry anymore. We're actually going to have to change that to spline. That looks better. So now we've got all 4 points on the arc, but only 2 on those side horizontals. So let's add in, we'll do a resample curve, plug that in, but that's going to resample all 3 curves at once. So let's do a named attribute and set this to Y side, plug that in, and now we've got control over just that Y side. You can do the same thing to control our X side. Just switch this to X side, plug that into our selection, and we can drop this down. I think 6 works. And then this isn't strictly necessary, but it's kind of nice to have control over all three of those curves, have control over the resolution for all three of those curves right here in the same spot. So I'm going to bring in another resample curve, and we're going to use Boolean math. So I'm going to plug this into a Boolean math NOR. So now when it's neither the y side nor the x side, then it must be that corner arc. I'm going to drop that down to 4. So now we'll put a frame around this and rename it to resolution. And that's where we can control the resolution for all three of those curves. Zoom in on that so you just get a good look at what's going on there. Next, we need to deal with, we look from the top down. These 45-degree angles at the corner are perfect. But when we come down here to where we're mirroring the geometry, or where we're going to mirror the geometry later, we actually want these to be perpendicular to the horizontals on the basket. And then as they come along, we just want them to kind of fan out until they get to this 45-degree angle. And if you look, basically all we're doing is scaling the y dimension from 0 down here up to 1. And conveniently, we have our spline parameter that gives us a factor for this curve, and that should give us the 0 to 1 that we're looking for. And we should be able to plug that in on the scale input on this instance on points. So let's bring this scale back. We'll connect it to a combine XYZ. And I'm going to start with these all at 1. And we're going to plug in our spline parameter to this y coordinate. And using that factor. And of course, it's controlling the scale for all three of those curves all at once. So we only want to use this factor when it is the y side. And when it's not the y side, we just want to use 1. So we're going to use a switch node. Change this to float. And again, we only want to use that factor when it is the y side. And for false, we just want to set 1. And then we'll go bring in another named attribute node. Change this to our y side. And now we're only scaling the y side, but you can see we're going from 1 at the corner to 0 at the origin. So the reason for that is that spline, we just have it, when we constructed it, we did it the other way around. So all we really need to do is just bring in a reverse curve, plug that in, and that should fix that. And then to get the x side, just do the same thing. We'll duplicate this switch and also the named attribute. Change that to the x side, plug that in, and then same thing, we're going to use a factor when it's true, when it is the x side, and we're going to plug that into the x on that combine XYZ. And then that gives us the verticals. We'll put this in a frame, call this basket verticals. Move that over a bit. Now at this point, we actually have, let me clean this up a little bit. We actually have from this separate geometry, we have all our horizontals, and we also have all of our verticals. So we should be ready to weave everything together and get the basket mostly done. So rather than go through and recreate all the weaving that we did for the previous tutorial for the round basket, we can actually just go up here to File, to Append, and I'm already in the last of the basket tutorial. So just go to wherever you have the basket tutorial saved, open that file, go to node tree, and then you can select this. I happen to know is the weave node. We just forgot to rename it, but control click and you can append all three of the main geometry nodes that we created in that tutorial. And I'm just going to go Shift A to group, and I'm going to use that node group, which I know is the weave node. And before we forget, I'm just going to go over here under node properties. We'll just rename that to weave. And then we can plug that right in. I'm going to change this to be on the flat because that's the verticals. And then we'll take from the separate geometry over here, we'll take the inverted selection and plug that into the weave. Now, it is weaving correctly, except that when we created the horizontals, we created these in 3 separate pieces, and we haven't connected them yet. So it's treating these 2 vertices as having separate indices, which is why it breaks them like that. So let's go back, and all we need to do to fix that, we're just going to add in a merge by distance. Plug that in there. And the reason it's complaining is because merge by distance only operates on mesh. So we're just going to do a curve to mesh right before this, which breaks our weave node because that uses the curve tangent property to figure out the normals. So if we go and just do mesh to curve and plug that in, now we have all our weaving actually working correctly. And at this point, I want to just mirror that geometry around so that we have all 4 sides of our basket. So right after this weave node, we can add in a transform geometry and a join geometry. And we'll plug that in. And then we can just go down to this scale for the Y. We'll plug in -1. And now we've got half of our basket. And if I duplicate this join geometry, Shift D, and also duplicate this transform, hit backspace to reset it, and we'll connect that in. And then for this one, we're just going to change the X to -1. And now we have our full basket. And now we're going to use another one of the nodes that we created for the round basket tutorial. We're just going to plug in, actually, so Shift A. We're going to plug in our curve to mesh with XYZ. And that XYZ, if you forgot, is just the UV unwrapping. So we'll reuse that as well. And for the profile curve, we're just going to use a curved circle. Bring the resolution down to 8, and we'll use 0.003 as our radius again. And now that we have that, we can see another issue. At the center of the basket where we mirrored everything, we have these breaks in the weave, and you can't really see it, but we were also duplicating this vertical. So we need to go back and do basically the same thing we did up here, where we merge by distance, and it has the same issue. So I'm just going to Shift D, copy all 3 of those, and we'll just go over here, and we can connect from our join geometry and connect that to our curve to mesh. And now you can see that's all one piece. And then I'm actually going to add in, we'll do a subdivision surface over here, just so that we can get our weave nice and smooth. And as long as we're reusing node groups that we already created, we can go back over here where we separated out the bottom of our basket. And we can add the twisted rim node, the decorative rim node group that we created. We'll add that there, but we're also going to have to mirror this geometry as well. So we're going to take, let's just add in another control point here. And I'm going to select all these, Control G. I'm not actually going to change anything, although remember to change the name this time, so we'll just rename this to mirror. I can move this closer. Then we're going to copy this, Shift D, over here, and we can take our, actually, just drop this onto that. And now we've got the entire bottom horizontal for the basket. And if we do Shift A, we should be able to find our twisted rim node. We'll plug that in and change the strand radius to 0.003. And I'm going to change the twist count. I think just 8 should be fine. So that's just the bottom. And if we go back here, duplicate this separate geometry and also the named attribute node, change this named attribute to top, plug that in, and now remember this selection is going to be the top and the inverted selection is the rest of the horizontals. So you want to make sure that the inverted is what gets plugged into that next separate geometry. Now, if you just duplicate, you just duplicated both of them at once, you can connect this selection, which is the top, and then connect those, and now you have your top decorative rim. I'm going to add a join geometry up here so we can connect those two together. You got the top and the bottom, and then create another join geometry down here so we can connect that right before our subdivision surface node, and then I'll connect that subdivision back up. So now before we get into the bottom of the basket, I actually want to do a couple of more things. First off, for this resolution, we're probably going to want to control this through the group input. So let's bring in another grouped input. Put that right here, and we're going to add in a few more inputs here. So let's add in, first we'll do a corner resolution, and then we'll do an X resolution, and just added too many. Add in a Y resolution, and I want those all to be integers. So we'll switch those all to integers. And then before we connect these, we're going to run into the same issue we did with the round basket, where if we change any of these to an odd number, so if I change this corner resolution down to 3, you can see these all end up lining up. It screws up the math that does the weaving. So we need to make sure that we don't ever have an odd number for any of these inputs. So what we can do, we can just take this to a multiply node, set this to 2, and then connect it to our count down here. And that's the Y resolution. So let's just bring this up to like it. I think 5 should be good. And then we can connect the same way to our X dimension and our Y dimension. So we'll connect that X and connect the corner. And of course, bring this up. 3's too much. We'll leave that at 2. And then change our Y dimension, bring that up to 3. So now we can control that from outside. And
this next thing is kind of a bonus tip, which can also be applied to the round basket tutorial. I actually picked this up watching a Kaizen tutorials video. I'll put a link in the description. It was kind of an unrelated video. I believe it was on the shortest edge node. But he just mentioned this in passing, and I realized it would really help with the way I had this basket set up. So to start with, let's go over, we're going to go to the corner profile, and we're going to change this up to 50 for the resolution, and that's going to give us this nice tight weave here. But what that also does is it brings up the vertex count. So if you look up here in the upper left, we have almost 1,000,000 verts in this geometry, and most of that is because of this subdivision surface. So if we hit M and mute this node, that brings us down to around 60,000 verts. But of course, the weaving looks kind of awful. So there's a way to do this, which saves a lot of geometry, but still gives us pretty similar look. All we have to do inside of one of those weave nodes, just add in a set spline type, and we'll change that from poly to Bezier, and then add in a set handle type, leave that on auto, and that's going to give us a curve, and you can see it cuts down the vert count to less than half. And also, as a side benefit, this multiply node is the offset for all of these, all the weaving, and 0.01 never corresponded to anything. So if you're using this method, you can actually change this down to 0.03, which is the same as the radius we're using for all of our profile curves. And you can see that actually cuts in a little bit. If you really want to, you can jump this up to 0.004. But that way we have basically the same look as we had before. And again, it's like half as many verts. Although to be fair, so if we tab back out of this, and if you look at the rim, that decorative rim, it still looks a little janky. So let's bring this subdivision surface up and unmute it to smooth out that rim. We can still bring this down to 1, and you can see we're still under half as many vertices, but it still looks almost identical. Okay, with that out of the way, let's start working on the bottom of the basket. And that's going to start pretty much the same way. We're just going to create a flat woven section for the bottom. So let's bring in another group input. And we'll put that down here. And let's start with this X dimension. So we're going to do the same thing we did for the rest of the basket. We're just going to create a quarter of it and then mirror the geometry across. So let's start by dividing this by 2. And we'll take that to a curved line, and I'm going to use that as an input to the length. Bring that up here. And because we're doing the X side of this, let's change the Z to 0 and change the X to 1. And we're going to have to resample this. So we can just throw in a resample curve node. And we're going to instance on points. We'll instance our Y lines, the perpendicular lines, onto this. So we can just take all of these, duplicate them down, Shift D, then plug the Y dimension into this divide node here, and make sure you change this direction so that the X is 0 and the Y is 1. Now we can just connect this line to the instance here and connect this line to the instance here. And then we should have those perpendicular lines. We do Shift A, we can add in our weave node right here and get those woven together. And you can see because we changed around the inside of that weave node, we already have those nice curves. And next we can just add in the mirror node we just made to get the full bottom of the basket. And then if we come up here, we can duplicate this curve to mesh with XYZ and then copy the same curved circle for the profile curve. And if we connect this to the join geometry here and view that, we've got the bottom of the basket. But similar to the round basket, if you come in and look close at the bottom corners, you're going to see extra geometry sticking out. So this is another deviation from that round basket tutorial. We're going to do something slightly different when we trim the bottom corner of the basket. And I actually got a couple of comments on this, and thanks again for all the feedback. It was really helpful. So a couple of people complained that the Boolean operation that we used to trim the bottom of the basket in that tutorial was actually a little unreliable. And I also found while I was animating the preview that I made for this tutorial that that Boolean operation is extremely compute intensive. So I found a different method of creating or of trimming that bottom of the basket that's much more efficient. So we're going to go through that. What we're going to use, if you come back up here, so these twisted rim nodes, I'm going to move these over a little bit. This bottom one here is the entire perimeter of the bottom of the basket. So what we can do, we'll just take this down here and plug it into a fill curve node and Alt-Shift-click so you can see what we're doing. And I'm going to plug in a translate or transform geometry. And we're going to translate this down just a bit. We just need it to be just far enough to be clear of the bottom of the basket. And actually I can show you what we're going to do. So we're going to add in a Raycast node. And show you what's going on. We're going to do a join geometry here just to visualize. Connect these together. So what we're going to do with this Raycast geometry, we're basically going to take from all of the vertices of our weave up here, and we're just going to, it's going to shoot rays down from that geometry. And what's going to happen is, if you look from the top down, what we're going to do is any vertices where we hit, where the ray straight down hits this other geometry, we're not going to delete that. Everywhere that it's a miss, we're going to delete that geometry. So where it's not a hit, let's go back out here, and I'm going to delete this join geometry. And we're going to take this is hit output from the Raycast node, and we're going to put that to a Boolean math not. And then we're going to connect this. Actually, let's just bring in a delete geometry node. Plug that in right there. And take this Boolean, plug it in there, and we should have, after this curve, the curve to mesh with XYZ. If we look at that, now we have a nice radius that matches up with the bottom of our basket. And if we add the rest of the basket back in, now we have nice clean geometry at the bottom of that basket and no extra geometry showing through. And like I said, this is actually much less intensive on the CPU. So this is a much more efficient way of doing this. And at this point, we should be able to just set the material. And we can bring in, if I do file append, we can just bring in, so same way we brought in those node groups, we'll just bring in this material, which again, I should have renamed. So now it shows up as material 01. And there you go, we have a square basket. But there's one more bonus tip that I can show you, which I actually discovered while I was working on filming this tutorial. Because of the way we laid this out, if we go back to the start on our corner arc, this resolution on the arc is controlling how many points we had on that original corner, and we resampled that later anyway. But if you take this resolution and drop it down to just 2, we actually have this interesting straight line here. Let me bump this up to 0.08, sorry. Make that a little bit more exaggerated. There. Now we have an 8-sided basket. I just thought that was kind of interesting, and it still looks pretty clean, although, yeah. So there you go. Just a little happy accident with this tutorial was that we could actually create even more variation on our basket. So I'm going to go down here. Let's just frame up the bottom of this basket here. Rename it basket bottom. And just zoom in on that so you can see what we've got there.
Thanks for watching. I hope you found this video helpful. If you did, don't forget to like and subscribe. And I would like to send a special shout out to Mark Corder for all his comments on my previous video and also for sharing his results. It honestly made my day. I'll put a link to his video in the description, and I would like to see what everyone else does with their results. So feel free to share something in the comments. Thanks again for watching, and I'll see you in the next one.